教我忘记助教可以开放那个线上，如果要同步进来，给他们进来，这方便吗？不勉强啊，就是那个 Moodle，如果下次要这样方便，可以开放他们同步进来。那我们会放在 YouTube 上面，谢谢。这两门课都一样，就这样可以同步上线。So start our lecture. Today is 14th, November 14th. So week 10th. Week 10th. Yeah. Today I will teach you the LDA, and I will teach you BQ. Hopefully that's part of HNN. So next week we'll continue teaching you about HNN, and then we'll start talking about the deep learning. So for the machine learning, the important part for the machine learning, I feel is those topics. One is the PCA. So what's the purpose for PCA? Many purpose. The major purpose we try to do is that dimensionality reduction. Dimensionality reduction. So suppose we have a lot of data. With a lot of faces, 1 million faces, we can reduce from 1 million faces transfer to 1 million eigen faces, and then we can reduce to probably only 100 eigen faces. So the dimensionality reduction a lot. And behind PCA, the important one is the singular value decomposition, like SVD, because original matrix we transfer to like a covariance matrix, and then we use SVD become eigenvector, eigenvalue, and the location matrix. The physical meaning. So the physical meaning for the eigen is the eigenspace. So from original space, according to our space, we transfer to the eigenspace. So that's the other space. The other thing is the original space, as I say, one image, suppose one vector. So we have 1 million faces. Sorry, one face is one vector. So 1 million faces meaning 1 million dimensional space. We can transfer to eigenspace. The same eigenspace is still 1 million eigenfaces, but we can reduce to only suppose 100, or 100 x's. So we'll reduce a lot of dimension. But the important one is that each eigenvector we also call principal component. What's principal component? That's meaning you extract the important vector. That's kind of attention. So when you learn the deep learning will tell you a lot of attention. Transformer talk about attention. So anything is attention. Attention is what? The important component. So the same thing. So behind PCA is a singular value decomposition. That's a factor analysis. So that's why when you study the high school thing, they have a polynomial, and then they transfer by the vector. When you high school do that. So why we need to do the vector analysis? This one, the same one. So that's for the PCA. So after you reduce the dimension The next step is for the classification. So we'll start talk about classification. The same as deep learning. Deep learning has an encoder head. What's the head, the purpose? Head will be, that's what your requirement. So head, the important for the head is loss function. So head is controlled by loss function. So you want to solve the loss function, that's optimization process. So in deep learning, the optimization process we use is a gradient descent, stochastic gradient descent. But in machine learning, for the parameters are not so many, just less than 100. So we can use Levenberger-Marquardt or expected maximization. Also, we can use the same. We can use stochastic gradient descent. That's the same thing. We can solve the loss function by optimization process. And loss function will corresponding to what? Two purposes. One is a discrete, the other is continuum. What's discrete? Discrete is suppose if you do detection, you will detect phase or not phase. So two classes. That's detection. For the recognition is one to many. We want to recognize your face, the other face, different person, different faces, face. That's one to many classification. So we have detection with the classification. We also can do the segmentation. Segmentation is that each pixel can be a foreground or background. So it's two classes. So all the head, the major purpose for discrete loss function is for the classification. But for the bounding box, you want to detect the face, suppose you want to have a bounding box. So you need to have a corner, the top left corner, right bottom corner, 2 points on bounding box. Let's continue. You want to approximate or approximate. Original bounding box quite big and approximate to the fit the head, fit the object. Then we need to use the continue process. Usually we use the mean square difference. So for the deep learning, only two kinds of head. One is a discrete, the other continue. Discrete is a cross entropy. Continue we use as a mean square difference. But we try to keep improving cross entropy, like the focal loss, different kind of cross entropy. Okay, and for the continue process, mean square error, but we add some regularization term, some constraint term. So that's the application for the head. So here, for classification, those are classification. PCA is a dimensional reduction. PCA is not for classification. PCA is for dimensionality reduction. And LBA, SVM, VQ for the classification. In deep learning, they improve SVM, they improve LBA. So when you use deep learning, okay, that's we call this sometimes okay, we do the GAN, GAN, the fake face. They use what they call discrimination. What's discrimination? That's classification. What's that? Discrimination? I will teach you is LDA. That's a fundamental thing, a fundamental for the discrimination. That's LDA. So I say deep learning for the classification, they all transfer from the machine learning, transfer the method from machine learning to deep learning. And then the deep learning result is better. It's better. Why is it better? Two reasons. One reason is that in machine learning, usually we input for raw data, the original data. But deep learning, they use encoder to extract the features and then input to the classification 不一样哈。就是我讲的 machine learning 通常是用 raw data 输出进去嘛哈，那 deep learning import 一直在萃取那些重要的资讯 extraction 放进去。And extraction right now has two kind of approach. One is a CNN. They use filter to extract the information. That's CNN. Right now, we use transformer. Transformer is what? Token. Token. So we input, we extract, we extract the information to be the token. And remember, token is 1D, not 2D. Our class, my background is computer vision. Computer vision is a 2D image or 3D voxel or temporal domain video. But no matter which one, we can do convolution, we can do transformer, we can become the token. Okay, but that's image. But the good thing is for the token, we do image. But right now, because token is from the language, speech recognition. So people think about how about combine the language and the vision together. So that's what we call vision language model, VLM. But how can you combine both different information or a token? So from the language, from the speech recognition, okay, you transfer those words, 那些字，把那些字 transfer to the token. Vision become page, 切一个 page 一个 page, and then transfer to the page is 2D, from page to 1D token. So all are token can combine together. For example, if this is a face, we just giving the image, but for the VLM, not only the face, we'll input a language for this FH face. 你要称它叫 face， 就会对应一句话或一个字，就叫有字有文字嘛，有文字有影像就可以 combine 在一起。那先独立做个 token 就可以 combine。So that's meaning visual language model is either image to text, TX 就字 or text to language, or combine together， 这是相通的。所以现在是你们 ，So right now you are living in the token time. Token 就是你现在居住在 token 的时代。所以为什么 token 重要 ？Token why is important? Because all the token can merge together. For what? For classification, for prediction, for text. You input the text to search. Input text, they'll find an image to you. You input the image, they'll output more image or output a text for you. Okay. And more application is communication. Because we have a video, we have a camera. So the computer start to communicate with us. So that's called agent. 你现在生活在 agent 的时代。But why right now the agent is not so popular? 就 agent 现在为什么不流行？还没那么流行？Because what? Because of large language model or vision language model have a huge parameters. The parameters is billion 10以上的参数啊，这电脑搞不懂，对不对？那不可能是那乱 except if you connect to the internet. So right now, AI PC is that we will reduce the billion parameters become million parameters. So they can run, while connect to the internet. The parameters reduction for knowledge distillation. KD, knowledge distillation, that's like a DeepSeek. They call that, they do the language knowledge distillation is reduce the model billion parameters become million parameters. So you don't need to connect with the internet. Okay, you can do the AI PC. So that's right now AI PC. Actually, behind AI PC is the AI agent. So agent will become popular. Okay. So back to here. So what I want to teach you SVM, I don't have time. Last year I teach SVM. So if you are interested about SVM, you can go to YouTube and check the lecture of last year. So the difference between LDA and SVM, what's the difference? I'll teach you LDA basically is two classes. Suppose you only use one line, I will teach you this one to separate both, like this one. You have two classes. LDA is you try to find a line to separate two classes. So that's we use LDA. So what's SVM? SVM is say, oh, this only one line is not good enough. How about we have a small region along the line. So it's not line, it's a small region. This region we call margin, M-A-R-G-I-N, margin. So SVM will include the margin, a small region. They can try to separate two classes. So SVM is better than LDA. But why don't teach SVM? Because last year we teach SVM. So this year I teach LDA. Okay, so SVM is better than LDA. But don't when right now you are living in deep learning time. Don't use LDA. Don't use SVM because deep learning has better results. deep learning已经把这两个东西取代掉了。So if you start not right now, like 5 years ago, like my student give me paper to filter for length. If I check the deep learning paper has SVM, I say this is not a good paper, just forget it. All the papers, they have a deep learning and then use SVM for classification. That's not good. No more. Okay. But for the concept, what I say, even though it's not good, but the deep learning, they use the margin, they use the concept of SVM right now. So what's the concept of SVM? I said one is a margin. The other is what? The other is they have a original mean square error plus one regularization constraint. Let's call it branch. 所以你们现在看到的 loss function, right now you check the loss function. They have an original loss entropy or original, mean square error. They have include one more term. This term we call regularization 调整，这个 term 在做调整。This term also called constraint. This concept is called Lagrange. Lagrange concept is from SVM. 就像你现在学到的那个 loss function， 很多都是从 SVM 的观念，就是把它过来是一模一样，结果比较好，大量的 data 这样子。Okay. So that I just try to explain to you. And SVM LDA is supervised learning. That's meaning you need to collect data. So SLDA and SVM is supervised learning. I will teach you vector compilation is unsupervised learning for fast tracking. Why I come back? This lecture, the VQ and HMA actually my thesis when I come back to Taiwan in year 2002. Come back here, I teach you guys, and then I put some VQ and HMA is my PhD thesis. I talk about it both. Okay, and I teach about 10 years. And I teach about 15 years. But in the same 5 years, I did not teach VQ. I did not teach you HMM because I don't have the time to teach you. But right now, this year, I start to teach you VQ and HMM. Why? Because large language, region language model. When you learn LLM, when you learn the VLM, they will tell you they use codebook. What's codebook? 你在学现在新的 model 都会跟你讲，我用 codebook 已经做出来了，他不会跟你讲，他只跟你讲我用 codebook 做完了。So what's codebook? That's VQ. So I come back to teach you the VQ. Why I want to teach you HMM? 我大概中间5年我都没有教这个了哈，因为现在我回来教你这个，是因为终于这个时代，他要把这2个东西我说这几年从那个 machine learning 要把它搬过来 deep learning 来成功了嘛，就 LLM 跟 VLM 成功了嘛，所以回来教你这个基本的东西，教你这2个。那 HMM 是一个 What's Markov model is very important. So when you learn reinforced learning, when you learn reinforced learning, or when you learn Mamba, you need to understand HMM. Okay, so I briefly teach you right now the deep learning. Okay, right now the hot topic, the LLM, the VLM. It's better to learn the VQ and HMM. So that's the reason I teach you. Okay, so next week I will start talk about the fundamental of deep learning, or the name Ericsson, something like that. The fundamental, the basic deep learning things. So we start talk about LDA. We start talk about. So it's a discriminant. The important discrimination of discriminant. That's meaning classification. Okay. And this is linear. That's meaning we call linear. That's meaning we have a nonlinear. So what's nonlinear discrimination? It's SVM. So SVM is nonlinear discrimination. SVM support vector machine include linear or nonlinear. Okay, but here I just teach you the linear. And SVM, I told you have 2 important issues. One is the margin. Okay, I already give you the lecture on the FTP side. One is the margin. The other is the branch. The two major issues. Okay. Back to discrimination is that suppose I have 2 class. And how can I try to separate or classify 2 classes? LDA is a supervised learning. That's meaning you need to label. So that's supervised, you need to label. So the final purpose, the last page is suppose whatever the start, bold, the start and small dot. How can you find this line in order to separate 2 classes? That's the purpose for LDA. So I'll teach you how to find this line. So the same, if we have 2 classes, how can I separate both classes? So first of all, because it's a line, okay, it's linear, so it's a line. A line, first of all, I will teach you is what's the equation? Line equation, 直线方程式嘛。The line equation is this one. Is suppose this equal gx equal to y. So suppose y equal to what's the result? W is a parameter times x plus constant term. Right, this is a line. Y equal to parameters w times x and plus constant term. so W0 is constant. So constant term equal to what? Equal to translation. Because that's affine transform. So constant term is shift. So the translation. That's meaning, for example, in this, we have a line, suppose L, this line. Because this line passes through the origin, 穿过原点 0, 0. So their translation equal to 0, right? So it's equal to 0 here. And then we have this is suppose it's 2D, two-dimensional space. So we have an x1 and x2. x1 equal to x, x2 equal to y. So we have x1, x2. That's meaning each sample of a 2D is x1, x2. So each sample collect a sample. So we collect a lot of sample, and it become two classes. And how can you find the L? So X is input data, 2D. And W1, W2 is a parameter like A, B, something like that. So this equation actually become AX plus BY plus constant C equal to 0. But here, the C equal to 0. And AB is transferred to W1, W2. And XY become X1, Y, X2. That's it. So what's the meaning for W1, W2? I teach you affine transform. So W1, W2, the location. Okay. But we ignore the scaling. Actually, W1, W2 include scaling. But scaling is a constant term. So we suppose the scaling equal to 1. Scaling 是变大变小而已啦，所以把它当成是1。那所以here W1, W2 are the rotation vector. So that's meaning what? Meaning the other meaning is that this is not. So you'll find this W1, W2 it's normal direction. W1 就是在一条线的 normal direction. W1, W2 become normal. Why is normal direction? Because original I said this equation here is that W1 times X1 plus W2 times X2 equal to 0. That's equation. But I told you, when you are graduate student or you are undergraduate student, the same. We do the coding. Coding cannot write the equation. Coding should do the vector or matrix. So equation form we need to represent by vector or matrix. So this will become inner product between the parameters and the input data. 我们要把 equation 程式不能写 equation 写程式了，你要写成 vector 跟 matrix 形式嘛。所以你会发现这个 term 用 vector 的形式来写变成这样子。So that's a vector W and vector X, the inner product, equal to 0. That's meaning what? Meaning they are orthogonal. 它们是互相垂直的。So that's meaning each line L is X1, X2. Their normal direction is a parameters W1, W2. And W1, W2, I told you is affine transform. So W1 and W2 control the location. So that's meaning this line, okay. So this is the L and normal direction W here. Okay, so you control the location. Because W is, I told you, W is location vector. Cosine theta and sine theta, right? Cosine and sine. So this W control the location of this line. That's important. Okay. So based on this concept, we continue. So our purpose is this way. Suppose this is a cluster. This is the other cluster. Each cluster has many samples on the distribution. So this one look like this one. We have two different dots here. So suppose two classes. So our purpose is to try to find a line L to separate both classes. That's a concept. But when we do that, we'll find, first of all, we'll reduce high dimension, no matter it's 2D, 3D, something. We'll suppose it's 2D. And LDA, PCA is a Gaussian model. LDA is also a Gaussian model. The best, because when I work in the United States, my company is the best face recognition in the United States at that time. 我以前的工作公司是全年最好的人脸辨识公司。We use LDA for face recognition, and the recognition rate is around, I think it's around 80. Detection rate is 90 something. But machine learning is about, using machine learning, LP is about 80% about face recognition. But we use margin. 我们那时候公司是把这个变成 margin 来做，提升到85%，也是用这个来做。那 right now the best face recognition, okay, right now in the world the best face recognition algorithm is from China. They use what? They use margin. They use what? They use SVD algorithm. The same. 他们是用这个来做。Okay, 那我再回到这一边。那 our purpose try to find the L, but I told you, okay, see this L is shift, right? Shift. So this L will shift along this W. W is the parameters. W control the rotation of this line. So in the other word to say is this L. Sorry, this two is different. This one is the L is this one, and W is this one. But forget this one. Later we will use this one. So L is this one. Remember W. If this one, this 9, if you see this 9, if you see this x-axis, the x-zone, x2, x1, you'll find W1, W2 are parameters, right? In the other word, if you say W1 is the axis, W2 is the other axis, x1, x2 become parameters. So that's what I try to say this way. This W will pass through this origin. That's important. L doesn't need to pass through the origin, but this W should pass through the origin. 这 W 一定要穿过原点 ，X 不一定，你 X 会 L will shift along the W, because W is the normal direction of L. W's normal direction, so W will pass through the origin. L will shift, okay, but W will control the rotation of L. Okay, that's the concept. So that's meaning if this 2D, if I project to the W, will become this distribution. And the other important issue is that any Gaussian model they project to the low dimension space, they are still a Gaussian model. Any Gaussian model in time domain or spatial domain, if they transfer to frequency domain, they are still Gaussian model. 这个观念很重要。Gaussian model 有几个重要的观念。 我刚刚讲的，你从 spatial domain 转到 frequency domain，高讯还是高讯，这很重要。第二个是我讲的，从高纬度转到低纬度，高讯 model 还是高讯 I will prove this one. So I just give you the concept. So if this 2D, we reduce to the 1D here, the distribution look like this one. Our purpose is try to separate both distribution. That's our purpose. So how can we separate both in order to find the L? So in this one, this two, I say this 1D, okay? We have a mean, we have variance of standard deviation, okay? So we compare both two. If you want to do the separation, you want to find the best W. You will find this one compared with the red one. This is better because in this one, the two mean are separate. The variance becomes small. So this one is easy to find a line to separate both classes. This distribution will overlap no matter you find any kind of L, you cannot separate both. So the purpose is try to find the best W in order to separate two classes. So that's the classification. That's for the generation for classes. So I say again, for the classes, you want to find the best solution. In this case is that if I can find a better W, and both classes sample can project on the W here. And this W is, if this case have a difference, meaning have a small variance, that will better result, you can separate. In this case, it's no good because they have an overlap. So the purpose is for this line, we try to find this line. Actually, the purpose is that we try to find the best solution of W1, W2, that's parameters. So that's the same as deep learning. So the deep learning, the purpose is how can we, based on the equation, based on the loss function, in order to find the best solution. And we try to solve the loss function, is meaning we try to find the best parameters. 是这样。好，我们目的是要找出最好的一组参数，这些参数可以让我们的分类分得越好这样子。那我以这个为例， so again, our purpose, we have a sample here. We try to find the discrimination line. But if we have higher dimension, we call hyperplane. 高纬度，超纬度，在超平面，这个超平面就是把这个两个 cluster 分开。Now, how can we find the hyperplane? Actually, the solution is how can we find the parameters W1, W2? And the parameter W1, W2 is a line you sample to project to the line. 这样子。So you will find your projection is not project to the L. No, you are project to the normal direction. Don't confuse. We try to find a line in order to separate both classes. It's meaning we try to find a line is W. This W is parameters 9. You will project on the parameters 9 and try to separate both classes. So that's purpose. 不要搞混了，是要找到是它的垂直的那个轴，这个轴。And the other thing is, I want to say F1. When you do the deep learning, we talk about F1. Oh, we have an F1 solution. So I will ask you, what's F1 the meaning, the physical meaning of F1? F1， 你这样很多大部分都不知道，我学生当然不知道。我们在做那个什么 deep learning 的时候，对不对？我们要 when you do the deep learning, we have a what? We have a recall here. We have a precision rate. Recall inverse is missing. Recall is that you detect an object. The object there, you face it here. You're missing that face. That's missing. You detect a face. That's called recall. So recall is what? The other precision. Precision is what? The other way is a false positive. What's a false positive? False positive is a false alarm. What's false alarm? It's meaning we don't have fire. But your fire alarm is have an alarm. 就是那个火警误触发那个火警，没有火警变火警的 alarm， 就是 false positive。这是相反的。Right? So when we do the evaluation, we have a recall, we have precision rate. But many papers say, okay, we use F1 because F1 include recall and precision. So what's F1? F1 is complicated. They have an equation talk about F1. Actually, F1 is here. It's equal error rate. In machine learning, we call equal error rate. 这是 overlap 是误判嘛？好，假设你找到这条线 ，here suppose this is face, this is non-face, right? And then you have threshold here, and this part is false positive， 你误判了，那这边是误判，那这个高度叫 equal error rate. Actually, equal error rate is F1. 我让你知道这个观念 ，equal error rate 上就 F1 的意思。为什么？因为 equal error rate 包括 missing， 包括 false positive， 是这样的。So in machine learning, we call equal error rate. In deep learning, we induce the other way is F1. So F1 will include the missing rate and the false positive rate. Will include recall precision. It's not average. 它不是平均哦，它不是平均，它是有一个数学式，但是数学式导出来就实际上就是 equal error rate， 让你知道一下是 overlap 的依据。So in this case, the equal error rate equal to 0. F1 become 100. Oh, that's good. In this one, overlap that's not good. Okay. So the concept here is what? The concept is that we try to find the L, meaning we try to find the W1, W2 parameters. But the purpose, we hope our Gaussian distribution become this one. This one is meaning we hope the inter and intra. What's inter? Inter meaning between. What's between? Between mean 1 and mean 2. Bigger is better. Bigger is mean separate. So inner or between is meaning that Gaussian distribution, the mean value between two mean value are large. Large is meaning they can separate. The other is intra. Intra is itself, 自己本身叫 intra. 自己本身叫 intra. Within. So intra also for within. Within is yourself. So we hope each Gaussian distribution, their variance smaller. Smaller is better. In all, so both we hope the variance 1 plus variance 2 for each Gaussian, smaller is better. Between is larger is better. That's the concept. Okay, so LDA, the concept for LDA is here. We hope we try to find the best W direction and W direction will let M1 plus M minus M2 become bigger. Variance 1 plus variance 2 become smaller as purpose. Okay, so the rest of the lecture we'll talk about how can we up the result. So again, we have the Gaussian model here in 2D, this cross dot, sorry, cross mark here. And this is a dot here. So two classes, and how can we find a hyperplane to separate both one? Okay, so we try to find a hyperplane here in this location. Actually, we will try to find the rotation W. So that's our purpose, try to find the rotation W vector. Okay, so this one we will project to become 1D, 2D become 1D, 3D become 2D, 4D become 3D. Reduce this one. So reduce this one. So we, first of all, the equation is here. First of all, I will go back to introduce it. Each point is simple. This one is each sample here. Each sample from 2D, we project to 1D here. So that equation is here. Each sample X is high dimension. So suppose S2D, we project to the W. W is unknown. We want to find the W. And then the projection result is Y. It's 1D. Again, this X is 2D, Y is 1D. W is a rotation parameters we want to find. So we don't know W. So we will solve W. When we solve W, we got an answer. Okay. So the next hour, I'll teach you how to optimize this result in order to find the W. 下周我们讲这个。Okay, we'll take a break. 休息一下。